Using these ideas, Bohr deduces what are the important quantities that determine the size of the atom. And the answer is incredibly unexpected. Okay, let's review the various proportionality relations that we'll need. We have the Boar relation, two pi r equals n lambda. And if we drop all constants, r is proportional to n lambda, or lambda is proportional to r over n. And remember, proportionality signs can be used very much like equality signs. All the algebraic things we do with equality signs, we are going to do with proportionality signs. So r proportional to n over r proportional to n times lambda is the same as lambda proportional to r over n. And then we're going to have a bunch of results from before. From the definition of EK and momentum, EK is proportional to v squared. This is just what I gave you in the first clip. And v is proportional to p, so v squared is proportional to p squared. And I'm going to give these guys names. This is going to be A. Then we have electrostatic energy, which is that EP is proportional to Z over R, where Z is the atomic number. Okay, next one we have is the Broglie relation, which is that P is proportional to 1 over lambda. Then we have the virial theorem. EK is proportional to EP. And now what we really needed was the Boar relation, which is that lambda is proportional to r over n. And I'm giving you these guys all names because I'll be asking you questions in chat, and the answers will be A, B, C, D, or E. And Bohr will put together these 5 relations, and you'll figure out what factors R depends on. He's going to figure out that R depends the size of the atom. R is the size of the atom. On the most unexpected of these variables, R depends on Z, the atomic number, and N, the principal quantum number. If you were to have asked me what would the size of an atom depend on, I don't know, I would say the mass of the electron, the charge of the electron, how fast it's going. I certainly wouldn't have picked Z and N as my variables, but that will be the consequence. And so let's see Bohr's mind at work. And so I'm going to say a relationship, and then you're going to tell me A, B, C, D, or E. EK is proportional to P squared. Put down EK, A, B, C, D, or E. That is A. P squared is proportional to 1 over lambda squared. Look at the 5 relations, it's a little harder. Which one is it? P squared is proportional to lambda squared. A, B, C, D, or E. Place it down. P is proportional to 1 over lambda. P squared is proportional to 1 over lambda squared. That's due to C. Okay, that's the kinetic energy. Now let's look at the potential energy. Potential energy is proportional to Z over R. Which relationship is that? A, B, C, D, or E? EP is proportional to Z over R. It's relationship B. And R, we're going to substitute for R n lambda. So EP is proportional to Z over R, which is proportional to Z over n lambda. And place into chat where this last one came from. That's right. R is proportional to n lambda, or this is the Boar relation. It's E. Give you a few seconds to look at all that, and I will continue. One over lambda squared. Look at the top relationship. It's proportional to EK. Why do I know EK is proportional to EP? Why is EK proportional to EP? A, B, C, D, or E? Put in chat. D, virial theorem. And EP we just showed is proportional to Z over n lambda. And so we're going to look at this guy is proportional to this guy. I'll write it over here. 1 over lambda squared is proportional to Z over n lambda. Just like in regular algebra with equalities, we can cancel a lambda, and we get 1 over lambda is proportional to n over Z. Or, turning that around, lambda is proportional to n over Z. Okay, lambda is not the size of the atom, but we're getting close. The size of the atom is R. So, R is proportional to n lambda. Which one is that? A, B, C, D, or E? R is proportional to n lambda. A, B, C, D, or E? Please put that in chat. It's relationship E. Therefore, lambda by algebra is proportional to R over N. We combine this relationship here with this relationship here, and so we get R over N is proportional to lambda. That's just a rewriting of this guy here. And lambda is proportional to N over Z. Just rewriting these two expressions. And now we get R over N is proportional to N over Z. And therefore, R is proportional to N squared over Z. And this is the relationship of R. R is the radius of the electron. And is therefore, it is the size of the atom. Because the atom size is not determined by the nucleus, by the electron. Its radius determines its size. Is proportional to the principal quantum number, N squared, divided by Z. Now this relationship has gone over in the notes. It's gone over in the pre-lecture module. And this recording will be done again. And you should follow at your leisure, making sure that you understand each of these steps. One final thing. If you have a proportionality relationship, there must be an equality. R is equal to some constant, and that constant goes by the letter A0, N squared over Z. A0 is the Boar radius, and it's equal to 5.3 times 10 to the minus 11 meters.